What we're going to be looking at today is the old brain. And what I mean by old brain is the older structures of the brain. So the first thing we're going to look at is the divisions of the brain. So we're going to draw the picture kind of in the middle. Okay, so over on the right-hand side is the hindbrain. So all the structures that we look at with the hindbrain are going to go on the right side. On the left side is the midbrain. And all the structures associated with the midbrain will go on the left side. Now the midbrain is also the limbic system. And the limbic system is what we call the reward pleasure center. And we had referred to that last week when we were talking about drugs. So let's take a look first at the hindbrain, specifically the brainstem. So we'll kind of draw it like that. So this is the brainstem. And the brainstem has two components on it. The first is the medulla. The second is the pons. So what the medulla does, the medulla is our life support center. So this is going to connect with our life support functioning, so breathing and heart rate. So if this part's damaged, it's death. The pons, there's two components we want to know, two functions. Okay, the first, this is where the nerves cross. So what that means, the nerves from the left hemisphere go to the right side of the body, and the nerves from the right hemisphere go to the left side of the body. So our right hemisphere controls our left side, and our left hemisphere controls our right side. The other function is it does have to do with producing chemicals for sleep. So what we are going to look at next week when we're talking about sleep, we'll look more at the pons then. Now, on the very back of the pons, of the brainstem, is the reticular formation. So the reticular formation, the function is it arouses the forebrain. So with it arousing the forebrain, what's going to happen is it's going to go from the, it's going to go up into the forebrain, and it's going to wake the forebrain up. So if this is not working, we're sleeping, and if it never turns back on, it's a permanent coma. Lastly, for the hindbrain is the cerebellum, which is located on the back of the brain. The cerebellum has two functions that we're going to look at now. We'll come back and add to it with cognition, but this is going to be responsible for balance and fine motor movement. So we are able to stay balanced because of the cerebellum. The fine motor movement would be things like playing an instrument, writing with a pencil. Okay, so that is how the cerebellum is going to help. So let's move on now to the limbic system. So kind of in the middle of the brain, we're going to draw this circle, and this is the thalamus. And the thalamus is sensory routing. And the sensory routing, what that means is that all of our senses, except for smell, go through the thalamus. So as an example, it's going to go from my eyes to the thalamus to the occipital lobe. Okay, another example, ears, thalamus, temporal lobe. Okay, and those are just two examples to help us understand what the thalamus does. So all senses except smell will go through the thalamus. The next one we're going to draw is below the thalamus, and this is the hypothalamus. And the hypothalamus is going to have the 5 F's. They are fight, flight, feeding, or Fahrenheit, excuse me, feeding, and fornication. Okay, so we have fight, flight, Fahrenheit, feeding, fornication. Okay, so what does this mean? It's going to regulate the sympathetic nervous system. Fahrenheit means it registers our body temperature. So when I start sweating to cool my body down, that's my hypothalamus. Feeding is going to be it's going to be reading hormones from the stomach and other organs and let us know when we're hungry and full. And then fornication, it's regulated with sexual behavior. Okay, so those are the 5 F's. So I kind of say them like fight, flight, Fahrenheit, feeding, fornication. Okay, number 3 is going to kind of loop around like a horseshoe. And this is the hippocampus. And this has to do with short-term memory. So the hippocampus is going to help us encode memories into long-term memory. So if this part's missing, we can't form new memories. We had talked about that with a case study at the beginning of the year with the case of HM. When when they removed his hippocampus, he could never really learn anything new. So that's going to be part of that. One way to remember this is a hippo, picture a hippo and a campus, like a college campus, and picture a hippo walking around campus. So a hippo always remembers his way around campus. So that has to do with short-term memory. Finally, we're going to draw 2 circles at the end. That's number 4. And this is the amygdala. And this has to do with negative emotions, especially fear. So if you can picture, so the amygdala has to do with negative emotions, especially fear. So we're really quick to respond to fear. And that's a survival mechanism. How I remember this is I want you to picture a girl named Amy G. Dalla. Okay, so Amy G. Dalla. And I picture her kind of like Regina George, okay, from Mean Girls. But if that's not something that's familiar to you, just picture some middle school girl who's a queen bee named Amy G. Dalla. She's really mean to everybody and everyone's afraid of her. Okay, so that can help you associate with the negative emotions, and then the fear is how everyone is afraid. So this is going to bring us to the end of the notes for the old structures of the brain. What I would like you to do now is you're going to go to the bio scenarios and complete numbers 1 through 10.